Welcome back to the deep dive. Get ready because today we're going where few have gone before to the fascinating intersection of AI and quantum computing.
Yeah, it's really cutting edge stuff.
Absolutely. And it's funny because this isn't just about all the buzzwords we hear.
Right.
We're going deep into a paper called Artificial Intelligence for Quantum Computing, and we're going to be talking about insights from experts in the field, including some folks at NVIDIA.
Yeah, what's so interesting about this is we're talking about AI as a tool to maybe even speed up
Oh, yeah.
the timeline to practical quantum computers. And I think
Yeah.
that's what makes this a really fascinating discussion.
Definitely. And the implications are huge, right? We're talking revolutionizing medicine, materials, everything.
Absolutely. I mean, this is not science fiction anymore.
Yeah.
This is like real world stuff that could change everything.
Okay, so we've got this paper we're diving into, but before we go any further, I think it's worth just taking a quick step back.
Yeah.
For anyone who, might not be super familiar with quantum computing, what are we actually talking about here?
So, in a nutshell, think of quantum computers as these like
Mhm.
superpowered machines that can tap into the world of quantum mechanics
Yeah.
to solve problems.
Okay.
That would take our normal computers, even the most powerful ones, like billions of years to solve.
Wow. So these are not just like slightly faster computers, we're talking like a whole different league.
Right. It's like the difference between, traveling by horse and carriage and like a supersonic jet.
Okay, I like that. That's a good analogy. So we've got these incredibly powerful quantum computers. But what really struck me in this paper is how AI is being used to actually build them.
Yeah.
It's not just about the algorithms themselves, it's about tackling these like real world engineering challenges.
Yeah, absolutely. One of the first hurdles is even understanding these quantum systems,
Yeah.
like how they work. They're complex.
Yeah,
And, even tiny imperfections can throw off calculations.
right.
So the paper goes into how AI is being used for this thing called quantum system characterization.
So it's like giving them a checkup.
Yeah, it's like a very thorough checkup, but way faster and more efficient than our traditional methods.
Okay, that makes sense. And they talk about this thing called Hamiltonian learning.
Right.
And I gotta be honest, when I first saw that, I was like, whoa, are we talking about history now?
Hamiltonian learning is like, think of the Hamiltonian as the blueprint
Okay.
for a quantum system. So it describes all the energy levels, all the interactions within the system. What's cool is AI can decipher this blueprint just by observing the system's behavior.
So AI is kind of like a quantum mechanic in a way,
Totally.
listening carefully to the engine, trying to figure out what's going on under the hood.
Exactly.
But it gets even cooler than that. They talk about AI helping map something called the disorder potential in a quantum device. Now, is that as scary as it sounds?
No, not really.
Mm-hmm.
But imagine you're building like a house of cards, right?
Okay.
And the slightest breeze can cause it to collapse.
Hmm.
That's kind of what we're dealing with in quantum computing.
Yeah.
Any tiny imperfection in the hardware
It can mess things up.
can completely mess things up.
Yeah.
So disorder potential refers to all these tiny imperfections that can throw off calculations.
Mm.
And AI is now being used to create a map
Oh,
for
wow.
these imperfections.
So we can hopefully fix them.
Yeah, exactly.
That's amazing. So it's not just about understanding these systems, it's about building better ones.
Right.
And the paper goes even further, talking about how AI is being used to optimize multi-qubit operations. Now, this is about scaling upright,
Yeah, exactly.
making them more powerful.
Yeah, the more qubits you have, the more complex the problems you can solve.
Right.
But getting these qubits to work together is a huge challenge.
Yeah, it's got to be.
So AI is coming in and optimizing these interactions, making sure all the qubits are playing nice together.
It's like a conductor leading an orchestra,
Exactly.
but way more complex, I'm assuming.
Way more complex.
Okay. And they even talk about AI designing the optical setups needed to create something called highly entangled states.
Yeah, entanglement. This is where quantum mechanics gets really wild.
Yeah, explain this one, because this is where I start to get lost.
Okay, imagine two particles that are so connected. They're like best friends who can finish each other's sentences even when they're miles apart.
Okay.
That's kind of what entanglement is.
All right.
It allows qubits to share information in ways that are impossible for our classical computers.
So AI is helping us choreograph these like intricate quantum dances.
Exactly. And these are essential for so many powerful quantum algorithms.
Okay, so speaking of algorithms, that's another area where AI is really making waves. And the paper talks about something called gate and pulse optimization, which sounds
Yeah.
very technical.
It is.
Can you break that down for us?
Imagine you're building a complex structure with Legos, right? You need to place each block carefully in the right spot. In quantum computing, those blocks are the qubits.
Okay.
And we use control signals called pulses to manipulate them.
So it's like giving the computer very precise instructions?
Exactly. And AI, particularly this technique called reinforcement learning, it helps us fine-tune those instructions. It's
Yeah.
like having an AI assistant that figures out the most efficient way
Yeah,
to assemble those Legos.
I like that, okay. But why is that so important? What's the big takeaway for our listener?
Remember how we talked about those quantum computers being super sensitive to noise?
Yes.
AI can make those instructions, those pulses, much more robust to noise. It's like writing a recipe.
Oh, okay.
That still works perfectly, even if you spill a little flour, you drop an egg,
All right. I can relate to that one for
Yeah.
sure. So AI is making them much more reliable, which is obviously a big deal if we want to use these things in the real world.
Right.
Okay, so now we're getting to the really interesting part, how AI is actually like rewriting those recipes for those quantum algorithms,
Yeah.
making them more efficient, less resource intensive, all of that.
Right. That's called quantum circuit synthesis.
Okay.
It's about figuring out how to translate a complex quantum algorithm into a series of basic operations that the quantum computer can actually perform.
So it's like taking a gourmet recipe with like 100 steps
Yeah.
and figuring out how to make the same dish with like 10 steps
Exactly.
without sacrificing any of the flavors.
And AI is proving to be incredible at finding those shortcuts. The paper goes into two key areas here: unitary synthesis and then generating compact circuits.
Okay, let's break those down a little bit. What's unitary synthesis?
So it's like taking a complex Lego structure and breaking it down into its individual building blocks. You're figuring out step-by-step instructions for building that structure from scratch. AI can help us find the most elegant and efficient way to break down these complex quantum operations into simpler steps.
Okay, and then there's generating those compact circuits.
Right.
So again, it sounds like efficiency is key.
It's all about efficiency.
Yeah.
In the early days of computing, even simple programs required tons and tons of code. Now we write more efficient code that does the same thing with way fewer lines of code. It's the same with quantum circuits. We want the shortest, most efficient way to implement a quantum algorithm, and AI is showing huge promise here.
Yeah, and they mentioned some cool examples in this paper, like Google DeepMind's Alpha Tensor Quantum.
Oh, yeah.
This one blew my mind.
Alpha Tensor Quantum is a perfect example of how this thing called reinforcement learning is being applied to optimizing these quantum circuits. One of the biggest challenges in quantum computing is reducing the number of these really expensive operations called T-gates.
Okay.
So it's like trying to minimize the number of times you have to use a really rare and expensive ingredient in a recipe. So by finding ways to use those T-gates more efficiently.
You're making the whole thing more practical.
Exactly.
Okay. And then there's another example in here that I found really fascinating, the GPTQE model,
Right?
which uses AI to basically come up with new quantum circuit recipes.
That's right. This is where things get really interesting.
Mhm.
GPTQE uses a type of AI model called a transformer, which has been really successful in natural language processing.
Right.
But now they're applying these models to the quantum world, training them on huge amounts of quantum data to learn how to generate efficient circuits. And what's really cool is these models can be trained on one type of quantum problem and then used to generate circuits for other related problems.
So it's like having a quantum chef who can take a recipe for chocolate chip cookies
Yeah,
and use that knowledge to create a recipe for peanut butter cookies
exactly.
without having to start from scratch.
Right, and that really speeds things up.
But we're just getting started, folks.
It's really amazing how AI can be used to find those shortcuts in quantum calculations. And the paper talks about this concept called parameter transfer.
Okay, so instead of starting from scratch, every time AI can learn from previous calculations, and that helps speed up new ones.
Exactly. It's like, when you're learning to play a new song on the piano,
Okay.
you don't have to relearn the entire musical alphabet every time. You use your knowledge of scales and chords to learn new pieces more quickly.
Right, right. So AI is kind of building up this like library
Right.
of quantum knowledge that it can apply to these new problems.
Exactly.
And they talk about how AI can even use something called graph embedding to find like similarities between quantum problems,
Yeah.
even if they seem completely different on the surface. So it's almost like AI is uncovering these like hidden connections
Right.
in the quantum world.
It's a bit like how a chess grandmaster can look at a random arrangement of pieces on a board and instantly recognize these patterns and strategies.
Yeah, that's a great analogy.
AI is doing something similar with quantum computing.
Yeah.
Finding ways to use past experience to solve new problems more efficiently.
So we're not even just talking about optimizing the existing algorithm.
Right.
We're talking about AI potentially helping us discover entirely new quantum algorithm.
Exactly. And that's a really hot area of research right
Oh,
now. And the early results are really promising.
that is so cool.
AI is incredible at, sifting through tons of data and uncovering those hidden patterns. And quantum algorithm design is really, really hard.
Mhm.
But AI could be the key to unlock these entirely new ways of solving problems.
This is getting very sci-fi very quickly.
It is.
Okay, but we can't talk about quantum computing without talking about one of the biggest challenges, which is
Right.
errors.
Yeah.
Yeah.
These systems are so sensitive to any kind of disturbance.
Absolutely. And so the paper talks about how AI is being used to make quantum error correction even better, and they talk about these things called decoders.
Yeah.
Can you explain what those are? Because that sounds kind of mysterious.
Yeah. So decoders are basically the error detectives in the quantum world.
Okay.
They analyze the results of these quantum measurements and try to figure out where those errors have crept in so that we can correct them.
So it's like a spell checker, but way more complex.
Yeah, exactly.
Okay, so traditional decoders can be pretty slow, right?
Yeah, and resource intensive.
Especially as we're building these larger quantum computers.
Exactly, and that's where AI comes in.
Yeah.
Researchers are developing AI-powered decoders that are much, much faster
Wow.
than those traditional methods. And we're talking about reducing error correction time from like hours to minutes.
That's incredible.
Yeah.
Okay, so the paper mentions they're using all sorts of different AI architectures for this.
Right.
Convolutional neural networks, transformers, graph neural networks. It seems like they're throwing everything they've got at this.
Yeah, it just goes to show how dynamic this field is. And some of these AI decoders are already showing like really remarkable results.
Okay.
There's an example in the paper where an AI decoder is actually running on like specialized hardware right next to the quantum processor.
Wow.
So it's enabling like near real-time error correction.
So it's like having this dedicated team of quantum mechanics
Yeah,
constantly monitoring and fine-tuning everything.
exactly.
Okay, but it gets even wilder. AI is not just improving the existing decoders, it's being used to discover entirely new error correction codes.
Right. And this is where AI's ability to kind of think outside the box really shines.
Oh,
Those traditional error correction codes were designed by humans, but AI can explore this like vast landscape of possible codes and find ones that are much more efficient
wow.
and tailored to specific hardware.
So AI is becoming a code breaker
Totally.
in the quantum world.
Yeah.
Okay, so this is all really exciting. We've talked about AI being used to design better hardware, optimize algorithms, and tame those quantum errors.
Right.
But what happens once we've run a calculation?
Yeah.
How do we make sense of those results?
That's a great question. And, reading out and interpreting that quantum data is another area where AI is super valuable. And the paper talks about this thing called efficient observable estimation, which sounds,
Yeah, that's a mouthful.
it is. But think of it like this. Quantum measurements are kind of like trying to listen to a whisper in a noisy room.
Okay, I can see that.
You're getting limited information and it's often distorted.
Yeah.
AI can help us extract more meaning from those limited noisy measurements.
Well, it's like a noise canceling headset
Totally.
for the quantum world. Exactly.
I like it. And then there's quantum tomography,
Right.
which is also mentioned in the paper.
Yeah, quantum tomography is essential for understanding what's going on inside a quantum system. Imagine you have this mysterious black box
Okay.
that's doing some incredible quantum stuff, but you can't look inside.
Right.
Quantum tomography is like taking a series of X-rays from different angles
Okay.
to reconstruct a 3D image of what's happening inside that box.
So we're creating a 3D map of the quantum world
Exactly.
using AI. That's pretty wild.
Yeah.
Okay, and then the paper also talks about readout measurements,
Right.
which is all about making sure we're accurately reading those final results
Exactly.
from that quantum calculation.
Yeah, it's like making sure the message isn't garbled when it comes out of the quantum telegraph.
Right, right.
And high fidelity readout is really important for making sure those calculations are reliable.
Yeah.
And it's closely tied to error correction.
If we can accurately read those results, we can more effectively identify and correct those errors.
Okay, that makes sense. And then finally, the paper touches on quantum error mitigation,
Right.
which is a bit different from error correction.
Yeah, quantum error mitigation is like taking extra steps to kind of clean up a really messy audio recording
Okay.
before you listen to it.
So it's more like damage control than perfect restoration.
Exactly.
Okay.
Got it. And AI is playing a role here as well. The paper mentions how AI can optimize these error mitigation techniques.
So again, AI is involved in like every step of this
Yeah,
process.
it's just another example of how AI is being integrated into every single part of this quantum computing workflow, from designing the hardware to running the calculations to even interpreting those results.
It's a pretty powerful tool.
It's a really powerful tool.
So we've covered so much in this deep dive,
We have.
from actually designing the hardware to dealing with these like really tricky errors.
Right.
It seems like AI is playing a pretty critical role at like every step of the way. But where does it all go from here?
Right.
What's the future look like?
Well, that's the big question. And the paper gives us some clues. One of the most exciting things is something they're calling accelerated quantum supercomputing systems.
Okay, so break that down for me. What does that even mean?
It's becoming clear that we're probably not going to just like replace classical computers with quantum computers. We're going to see these hybrid systems where powerful classical computers work alongside these quantum processors.
So it's about using both of them
Yeah,
for their strengths.
exactly. Leveraging the strengths of both. Classical computers are good at certain tasks, and quantum computers are good at others. By combining them, we can solve problems that are just impossible for either one alone.
Okay.
And AI is going to be essential in managing these complex hybrid systems.
So it's almost like AI is the conductor of
Honestly,
this like technological orchestra, just
yeah,
making sure everything's working together.
yeah,
Okay, so another really interesting possibility that they mentioned in this paper is AI being used to simulate quantum systems.
yeah.
Why is that so important?
Well, simulating that quantum behavior on our classical computers is really, really hard. But it's crucial for developing and testing new algorithms. It's kind of like if you're designing a new airplane, you don't just build it,
Yeah.
You want to simulate the aerodynamics to make sure that it's going to fly.
Of course.
And AI is already being used to create these more efficient to more accurate simulations, and that could lead to a lot faster discoveries.
It's like having a virtual quantum playground
Totally.
where you can test things out. Okay, so this is a big one. Could AI actually help us invent completely new quantum algorithms?
Oh, that's the million-dollar question, right?
Yeah,
And it gets at the heart of scientific discovery. It's a huge challenge.
yeah.
But AI might be the perfect tool to do it. AI is amazing at analyzing huge amounts of data, finding patterns, and making unexpected connections.
Right.
So AI could help us crack the code of quantum algorithm design.
So we're not just talking about AI helping us with quantum computing.
Right.
We're talking about AI potentially becoming this like co-inventor,
A partner.
a partner in the quantum world.
Right.
That's incredible.
The future is full of promise, but, it's also a little bit awe-inspiring.
Yeah, definitely a little scary too, but
Yeah.
in a good way.
Yeah.
Okay, so big takeaway for our listeners today. AI is not something out of a sci-fi movie. It's here, it's now.
It's happening
It's a huge part of this quantum computing revolution. This is a field that's changing incredibly quickly.
rapidly.
And all the stuff we talked about today is really just the beginning.
It's just the start. We encourage everyone to check out the research paper we've been discussing and just stay curious about what's coming next, because the future is unfolding right in front of us.
Couldn't have said it better myself. And of course, be sure to subscribe to The Deep Dive for more deep dives into the world of science and technology. Thanks for listening, everybody.
See you next time.